Hi students, welcome to Vijay Datta chemistry classes. This is Purnima Mam. Today we are going to discuss hydrocarbons, right? So hydrocarbons, what are called hydrocarbons and how many types of hydrocarbons we have? Let us discuss. Hydrocarbons. Hydrocarbons are nothing but the carbon hydrogen containing compounds are called hydrocarbons. Any other atom, that is nothing but any oxygen, chlorine, nitrogen, any highly electronegative atom involved in that, those are different. Only carbon and hydrogen containing compounds are said to be hydrocarbons. Okay, so how many types of hydrocarbons we have and what is the use of hydrocarbons in our daily life? Most of the fuels are hydrocarbons. Most of the fuels we are using are hydrocarbons. Example is LPG, liquefied petroleum gas, a domestic fuel that causes least pollution. This we are using for the domestic purpose and it releases the least pollution. This is a liquefied petroleum gas. Like that, only one more hydrocarbon, that is CNG. This is called compressed natural gas. Compressed natural gas. It is liquefied petroleum gas. It is liquefied petroleum gas, compressed natural gas, and LNG also we have, that is called liquefied natural gas. All these are the our daily life we are using these hydrocarbons, liquefied natural gas, right? So this liquefied natural gas which is used as automobile fuel, this one we are using as the automobile fuel, like we are using this one. And also this one natural gas is found in upper region. During this one we are getting from the drilling purposes, drilling of oils, wells and all, petrol, diesel, kerosene, oil, and are the fractional distillation of the petroleum only we are getting all these type. And also coal gas is also obtained by destructive distillation of coal. All these are said to be the hydrocarbons only. Mainly the definition for hydrocarbons are carbon hydrogen containing compounds. No any other heteroatom will be present in that. Carbon and hydrogen will be present in that. Those are said to be the hydrocarbons. Let us see here the classification of hydrocarbons. Classification of hydrocarbons. Hydrocarbons classification. Here two types of hydrocarbons we can see. The first one is saturated hydrocarbons. Saturated hydrocarbons. Another one is unsaturated hydrocarbons. Another one is unsaturated hydrocarbons. So saturated hydrocarbons are said to be aliphatic we can be. See here, again this classification, the saturated hydrocarbons and unsaturated hydrocarbons, we can consider as aliphatic hydrocarbons and aromatic hydrocarbons also. Whatever we written the saturated and unsaturated comes under the aliphatic hydrocarbons. These are aliphatic hydrocarbons. And we have one more type, that is the aromatic hydrocarbons also we have. But this is the aliphatic hydrocarbons, again two types, those are said to be saturated hydrocarbons and unsaturated hydrocarbons. Let us see what is meant by saturated hydrocarbon. What is the saturated hydrocarbons? Saturated hydrocarbons are nothing but alkanes. Saturated hydrocarbons are nothing but alkanes. These are only we are studying as the alkanes. Unsaturated hydrocarbons are, unsaturation will be present in that. That is, those are alkenes and alkynes. Unsaturated hydrocarbons, alkenes, alkynes. Okay, see what, how to define the saturated hydrocarbons. Saturated hydrocarbons, these are the compounds in which all the four valencies of carbon are satisfied by the atoms or groups. These are also known as paraffins. Very, very, very important. What is saturated? Carbon's valency is 4, right? All the valency of the carbon will be satisfied. That is nothing but the tetravalency will be fulfilled by the hydrogens, and only sigma bonds will be present in the saturated hydrocarbons. These are known as these saturated hydrocarbons. Example is alkanes. Only single bonds will be present in this, and these alkanes is also known as paraffins. Come to the unsaturated hydrocarbons. These are the compounds in which two carbon atoms are linked by double or triple bonds. In case of saturated hydrocarbons, the carbons are attached only with the single bonds. That too, carbon-carbon single bond or carbon-hydrogen single bond. Because as the hydrocarbon we defined, only carbon and hydrogen will be present in that. So, the single bond present between either carbon-carbon and carbon and hydrogen. Comes to the unsaturated hydrocarbons. Unsaturated hydrocarbons here, these unsaturated hydrocarbons, they will be present in this also. Only carbon and hydrogen will be present, but carbon carbon double bond or carbon carbon triple bond will be present in this type of hydrocarbons. For these are the examples. If double bond is present between the carbon carbon, those are said to be alkenes. If carbon-carbon triple bond is present, those hydrocarbons are said to be alkynes. And here one question, there cannot be a carbon double bond hydrogen, carbon triple bond hydrogen is not possible. Only carbon single bond hydrogen is possible. Why carbon double bond hydrogen, carbon triple bond hydrogen is not possible? Hydrogen's atomic number is 1. So its electronic configuration is 1s1. So only one electron is available for the hydrogen. Only this hydrogen, by donating this one electron or by sharing this one electron with the carbon, it can form a bond. That's why always carbon hydrogen exists with single bond only. No double bond and triple bond between the carbon and hydrogen. Carbon carbon double bond can be exist, carbon carbon triple bond will be existed, because carbon is a tetravalent in nature. It can form the single bond, double bond and triple bonds also it can be formed. Okay, so these are the these two are said to be alkenes and alkynes. These are said to be unsaturated hydrocarbons. The example for alkenes is C double bond CH and HH. This is called ethylene. The name of this compound is called ethylene, and CH, C triple bond CH, and this is also H. This is called acetylene. Acetylene is its common name. Acetylene is its common name, and its IUPAC name is ethine, or also we can take. See here, ethylene is its common name. Ethene is its IUPAC name when double bond is present. So this is about the hydrocarbons. In our daily basis we are seeing some hydrocarbons, and the classification of hydrocarbons: aliphatic hydrocarbon, aromatic hydrocarbon. Again, aliphatic hydrocarbon can classified as saturated hydrocarbons and unsaturated hydrocarbons. Again, the unsaturation is present in alkenes and alkanes. So total, I'll take the flow chart like this for hydrocarbons. This is the flow chart for hydrocarbons. Hydrocarbons, two types. First one is aliphatic hydrocarbon, and it is aromatic hydrocarbons. Aliphatic hydrocarbons again classified into two types. The first one is saturated hydrocarbon, unsaturated hydrocarbons. In saturated hydrocarbon again classified into alkanes. These also known as paraffins. Unsaturated hydrocarbons again classified based on the double bond: alkenes and alkynes. Aromatic hydrocarbons are classified into benzene. Examples for aromatic hydrocarbons are benzene and its aromatic hydrocarbons. Aromatic, and also this one we can say as a cyclic aromatic compounds. Okay, the aromatic is nothing but the cyclic aromatic, because it should have a 4n plus 2 pi electrons. So we'll study in aromatic hydrocarbons. The best example is benzene. So this is about the hydrocarbons flowchart. So today We are going to start our hydrocarbons with this one, saturated hydrocarbons, that to alkanes. Alkanes are also known as paraffins. So let us see how will be the order for the alkanes study. First we have to see alkanes nomenclature. Next, any isomerism is present, we have to check. And next, methods of preparations of alkanes. And next, physical properties. Next, chemical properties. And then uses. So this is the order while we are studying one of the functional group in the organic chemistry. All these points are important only. This is the order we have to prepare the one of the for the exam point of view. Either it is in NEET mains point of view. This is the order we have to prepare organic chemistry for every functional group. Suppose if you are preparing for alkyl halides and aryl halides, what is the nomenclature? What is the isomerism present in alkyl halides, aryl halides? What are the methods of preparations? What are the physical properties? What are the chemical properties? And what are the uses? This is the order. So today I am going to discuss with the nomenclature and isomerism. Okay. Let us see what is the nomenclature of the alkanes. Already we know the nomenclature. See what is the general molecular formula for alkanes. General molecular formula of alkanes is CnH2n plus 2. CnH2n plus 2. If you substitute n equal to 1, then C1H2 into 1 plus 2. So it is CH4. Then what is the structure of CH4? See, carbon having the 4 hydrogen, CH4. This is the structure. One carbon is present, then that root word is called meth. And what is the functional group? All are single bonds only. So the name of this compound is methane. When you are taking n equals to 2, then the molecular formula will be C2 H2 2 jar 4 plus 2 6. So C2H6. How to write this compound? 2 carbons and 3 hydrogens. As this is the alkane formula, then all are single bonds only. So this is the structure. So it is hydrogen, hydrogen, hydrogen. Here also hydrogen, hydrogen, hydrogen. So two carbons are present. So root word is eth. All are single bonds. So it is called ethane. So the only one bond is present, that is called sigma bond. Okay, only one bond. All are total 7 sigma bonds are present in this C2H6 structure. Its name is like this. So this is the complete structure. If you want to write bond line structure for C2H6, this is the bond line structure. Here is one carbon, here is one carbon, and you have to check carbon's tetravalency. This carbon has one bond, so you have to imagine other 3 hydrogens are presented. Here also the carbon is with one bond, so remaining 3 hydrogens are present. Like that we have to consider. Suppose if you are taking N is equal to 3, then the formula is C3H6 plus 2, that is nothing but C3H8. So I'll take 3 carbons. All carbons are attached with single bond only. Then 8 carbons it should be. So 8 hydrogen should be. So 3 hydrogens are completed. This is also 3 hydrogens are completed. Just check these carbons 1, 2, 3, 4 tetravalency completed. For this carbon 1, 2, 3, 4 tetravalency completed. Come to this carbon only 1, 2, 2 completed. So 2 more bonds are required here. So total 1, 2, 3, 4 tetravalency is completed. Now check the formula C3 1, 2, 3, 4, 5, 6, 7, 8. C3H8 formula is fulfilled. Comes to here. It is the complete structure. If you want to write its no structure, then you can write simply like this also. CH3, CH2, CH3 you can write. Otherwise, if you want to write here bond line structure, you simply write like this. Each dot indicates the carbon. So here carbon is having only one bond, so remaining three hydrogens are there. This carbon is attached with the two bonds, so two hydrogens are present. This carbon is attached only so remaining three hydrogens are present. This is the bond line structure. And come to the name of this compound, three hydrogens are present, so it is the root word is prop, and all are single bonds only. Obviously you have to add in the suffix "ane", so the name of this compound is propane. Like this we have to do its nomenclature. This is the nomenclature of the alkanes. We can go with one more example, n equal to 4, then C4H10. Then you have to go with four carbons, each carbon single bond. Then arrange with the hydrogens, share with tetravalency. Only two bonds are there. Here one more hydrogen, here one hydrogen. Only two bonds. Here hydrogen, hydrogen. Here only two bonds, hydrogen, hydrogen. So C4, 3, 4, 5, 6, 7, 8, 9, 10. C4H10 was satisfied here. Then this one you can write as CH3, CH2, CH2, CH3. Otherwise you can write CH3, CH2 came two times, so taken twice CH3. This is also shortcut writing the formula. And if you want to write the bond line structure, four carbons, it is first carbon, second carbon, third carbon, fourth carbon. It is the bond line structure for C4H10 and C4. Four carbons are there, so root word is but. All are single bonds, butane. This is what the nomenclature of the alkanes. Whereas come to the isomerism. See, isomerism is nothing but we have to check the isomerism. Structural isomerism we have to check, stereoisomerism also we have to check. Generally alkane shows structural isomerism. In structural isomerism again we have a five types: chain isomerism, positional isomerism, functional group isomerism, tautomerism, metamers. So in those isomers, in structural isomers, this alkane shows chain isomerism and positional isomerism, they will be shown. Chain isomerism and positional isomerism will be shown by this one. And also these alkanes shows optical isomerism also. This alkanes shows in stereochemistry optical isomerism, and it shows conformational isomerism also. See here, what is meant by conformational isomerism here? Which type of isomerisms they are showing? Chain isomerism. Example is, suppose here I am taking, see, CH3, CH2, CH2, CH3. This is what the chain isomerism. See, positional isomers, chain isomers, both are same. So we can take any one chain isomerism like. So this chain isomerism only, the same molecular formula, it is C4H10. Simply I will write just like this. CH3, CH2, CH3, and here one CH3. I'll remove one hydrogen. Say, then check its molecular formula, C4H10 only. So same molecular formula is same, but differ in their structure. Those are said to be chain isomer, structural isomerism, and differ in the chain, right? So these are two are said to be chain isomers to each other. Like that it will be shown. Comes to the optical isomerism, they are chiral and achiral. Carbon having four different groups, then that is said to be the chiral. Alkanes, they can have four different groups. See here, here it is, one is hydrogen, another one is CH3, one more is C2He5, another side is C3H7. If you have like this carbon is said to be chiral. That is nothing but optically active, because four different groups are attached to this carbon. So this is said to be optical. So alkanes will show optical isomerism also. Whereas come to the alkanes, the special isomerism we'll study, that isomerism is conformational isomerism, which is very, very, very important. Conformational isomerism. What is this conformational isomers? Again here we have to study the conformers, Newman's projection, Sahar's projection. And what are these conformational isomers? Right? So these conformational isomerism we will be study in our next video. Okay guys, thank you. If you understand the concept, please do like, subscribe and comment. If any required topic if you want, I'll take that topic. Okay. Conformational isomerism will be seen in the next video. Thank you. Thank you so much.